So yeah, welcome everyone. Just so you're aware, the recording is so that we can put this up on YouTube for anyone who was unable to make it. They can view it and hopefully get some worth out of what we're discussing here and what we're showing here. Obviously, as we've advertised, the second half of this Newcomers workshop is going to be a bit more interactive. So the questions that you're going to ask might not be relevant to them, but it's a new format and hopefully it's useful to you guys who can actually attend to it right now. So yeah, I've got my colleague Dimitri Avram here with me. So my other colleague Stuart Wheater is going to join a bit later. He's got a commitment right now, but he's going to be around for the second half where we're answering your questions and going into the breakout to try ourselves. So anything else before we start? Oh yeah, if you have any questions, feel free to type them in the chat. Dimitri will be watching the chat, and if there's any clarifications needed or anything that needs to be addressed, Dimitri will bring it to my attention. We can pause the presentation or the live code demo, and we can get that cleared up before continuing. Right, so yes. Next slide. So this is just a quick overview. So we've just started. The slides won't take very long. And then we've got a good 50 minutes of code demo where I'll talk you through the R script that I prepared earlier. And then the second half will be from sort of 12:05 to 13:30. That's UK time. So +1 hour for anyone in Europe. And it's just going to be a breakout. As I said, it's the first time we're doing this. So whether we open breakout rooms will depend on whether there's lots of different threads of questions. We're flexible, so if you feel like you want a breakout room, do tell us. And then we'll ask you for feedback, and there'll be time at the end for any more general questions. Well, I'm sure there'll be time in the breakout as well if you have something pressing. So what is DataSHIELD? Well, DataSHIELD is a tool for analyzing data that you can't access or view in the normal way. So this can be for a variety of reasons, such as patient confidentiality in a medical cohort study, or intellectual property protection in a commercial setting. So regardless of what it is a restriction and you must work with it. So DataSHIELD provides ready-made ways to do so. So in DataSHIELD, you request a result and the system is set up to decide whether or not that result is too revealing of the low-level details of the data. And if it is too revealing, you are blocked from seeing the result or the answer that you were looking for. This is called active disclosure protection, and it's very useful to give data owners and custodians confidence that their data is not going to be misused, and therefore makes them more likely to share their data under DataSHIELD protections in the first place, allowing you, the researcher, to study more data. DataSHIELD also has what's known as federated analysis. So that's where the data is stored all around the world on the servers, often where the data was gathered in the first place. And the commands go to the data. So a small little package there going to the data server, rather than the original data being transmitted to the analyst and possibly being incepted along the way. So it's both efficient distributing the computing load and also statistically powerful by increasing sample size, as I said earlier. It increases the statistical power of your results. It also avoids the challenge of transmitting large data quantities. So the large data sets can sit in place and data light queries are sent back and forth instead. So next slide is a more detailed animation of the federated analysis structure. So flashing there is the DataSHIELD logo. That's us up in Newcastle upon Tyne in the northern England. And so we'll have a look inside each of these computers. So the orange is the analyst's PC. They're running an R session, possibly an R studio. And meanwhile, in the data server, the blue side, that's where the data is being stored. The custodian or the data owner will give you the login details once you're verified as a trusted researcher, and then you'll enter them and they will be transmitted to the server to verify who you say you are and set up the R session. So that's loaded in the data, and the connection is known as the DataSHIELD session. Now you write your script, whether that's finding the averages or the measures of spread, or possibly even linear models. And then you can, when you hit enter on those commands, they are sent to the server for the server to then crunch the numbers and generate the result. It's at this stage that the active disclosure protection takes place. And if you've asked for something that is too revealing of the data, then it will block you at this stage. And then if the results are fine, then they're generated and then transmitted back to you. Meanwhile, that happens all across the other servers, and they're all transmitted back to the analyst session, and then they get aggregated into the meta-analysis results. So, some key properties of DataSHIELD to keep in mind. DataSHIELD uses the R language, so hopefully you're familiar with that, but there's plenty of online learning resources out there for it. The analyst sends commands from an R session using the pre-installed DataSHIELD libraries. The servers which also run DataSHIELD libraries receive the commands, conduct the analysis, check it's not disclosive, and send back the results. And lastly, we're just noting that it's open source. This means that the code is freely available through GitHub for you to inspect and even modify it if you wanted to. So this is drawing to the end of the presentation, but to give you a sense of what we're about to do, we're about to look at a script that I've written that analyzes some Titanic passengers data that we've downloaded from Kaggle. And in preparation, I've split it in half to simulate these two these two servers as if they'd been gathered in different places. So like, say there's two ticket offices and each stored their data set locally. It is quite suitable for the purposes of DataSHIELD because it does contain individual personal data about individual passengers of the Titanic. So if the Titanic was sailing today instead of 100 years ago, then there would be confidentiality issues around that, which DataSHIELD is well suited to solve the problem of analyzing. So I'm about to transfer into RStudio and show you some of the R script. And remember, you get to have a go at this script later in the breakout. If you want to play around with anything, do something in a different way to work out how things work. So I need to do a new share. And someone let me know if you can see that.
Yes,
Cool.
we can.
Thank you. So here in RStudio, hopefully some of you are familiar with this. What I'm running here isn't a regular script. It's instead an R Markdown script instead. So you've got this markdown code here, which we can use to generate an HTML of the results if you wanted to see it in a more presentable format. And then also in amongst the text, we've got the R commands written in these segments here. So as this is hosted online and you might be downloading it later, you may need to install the R Markdown package if you haven't already got it on your RStudio or R instance. So we've already shown you the presentation. So then you need to prepare your analyst DataSHIELD session. So the client session, in fact. So I've already done it, of course, because I've been preparing for this presentation, but you will have to install these 3 packages, which contains all the functionality that you'll be needing to actually run DataSHIELD commands. On the other hand, you won't be needing to install anything for the server, as has happened in previous workshops, because we're connecting to a server that is used for training purposes for DataSHIELD, hosted by Yannick in France. So I'll skip past this, but remember that you can do it later when you need to. But I will have to library all 3 packages that I've pre-installed. So important not to forget that, else the commands that you run will not be understood by R. So I had the results to keep it tidy. So this is the main server that we're going to be connecting to. So let's just quickly go across there and have a look at it. So new share. Oh, there we go. Share. So I logged in as just a check earlier, but I'll log out. So the username is dsuser and password is the @ SSW0RD. Sign in. So where you go next is to projects up here in the top left. And then this is a list of all the various datasets stored on this particular server. So we're interested in this Titanic Newcomers workshop. And then this is the dashboard, so it's some very basic info. We want to look at the tables, which is here on the left panel. And here we can see the different datasets available inside the project. So we've got 1 and 2. Let's have a look at 1. Oh, this is the number of columns and the number of rows. So that's useful to know. So we've got data such as whether they survived, the passenger class, name, passenger sex, age, etc. So this data dictionary will be useful to come back to later. We've got full comments in the chat, Dimitri. Is there anything important to note yet?
No, I responded to one question.
Sure. Transfer back to RStudio. So yeah, those are the username and password if you want to log in later. So the first thing to do in a DataSHIELD analysis is actually connect your R session to the server. And you do that using a login data frame. So first of all, you create a local object called builder, and then use this DSI function, new DS login builder, DS for DataSHIELD. So often what you'll do is just have one of these, find it from the documentation or whatever, and then paste it in and then customize the specific arguments. So I've already done it in preparation. So here's the URL. Here's the username and password. this is the server we're connecting to. So we saw on the list of projects, it was called Titanic Newcomers Dataset 1 and likewise 2. Another important argument here is table. So this is in the format project name, and then this little dot here, and then server name. So it's the Titanic Newcomers Workshop dot server 1 basically. And then the second part of this builder is appending the login information for the second study. So the second data set of passenger data. And then finally at the end, you've got this build command here. So as I say, this is all something you can copy and paste in from another source and then customize the actual arguments. Later on, we can, in a breakout session, if you want, you can try building it yourself to actually learn which part does what. I'm going to skip past that and highlight this key command here, which is the login function. So this is the function that will actually start your connection to the server. And what happens is you take the login data that you just built up in the login data frame and then plug it into this DataSHIELD.login function, which is part of the DSI package. And and this symbol here is important. So we're going to call the object on the server that we'll be addressing D, which will stand for data frame. And this connections object here will be useful because this is a local object, but you'll be able to use it later to address either all studies or just the first or the second study. So you have to pay attention to what you call this. I often call it connections, but there's other people have different conventions. So this one actually has some output. So it has some information that it's successfully logging into all the servers. So if it's a bigger study that you're connecting to, this might take some time, but that's okay, as long as it completes. And then you're also assigning the table data that also has to successfully connect. If there's any problems with your connection, you'll more than likely see it here, and you'll have to have a look at the error message to work out what's gone wrong. So for example, I prepared earlier something where I'd made a mistake. Yes, well, this will go wrong. So if I run it, so here it's gone wrong because we put the wrong username and password in. So if I corrected that to password, I'll delete the second one. And then if we made a typo, Titanic servers 1, and then tried it again, commented. Not sure why that is going wrong. Oh, capital. There we go. So that successfully logged in because we're not getting the 401 error anymore. So here it's throwing will be excluded because that table that we asked for is not accessible. So here we need to go into the Opal portal and work out what mistake it was. So important to very carefully pay attention to what project you referenced and which study within the project you referenced. So once you correct that back to server 1, click it and it does the successful login again. So moving on, now that you're actually connected, I'll actually run this one again because I want to be connected to both servers, not just the one. So yeah, once we're actually connected, you can start to work out what you want to do with the data. So, so obviously, unlike in a normal data analysis, you can't actually just look at the data set to get the impression of it. So you have to use functions to deduce and interrogate the data to get what you need to know to perform your subsequent analyses. So, for example, you might want to know the dimensions, how many rows and columns. Yes, you've already logged in. We've already logged into the Opal online portal, but you may not have. You may just want to quickly generate it here. So, DataSHIELD function syntax is going to be ds dot for, I think, all DataSHIELD client-side functions. So lowercase ds dot and then dim here for dimension. So this is often similar to what you'd find in the base R functions, but it's not always guaranteed. So you should go and check the library of various functions that we've got available so that you don't make any mistakes just by assuming. So obviously here, the question mark in R is going to do a query on the help documentation. So if we run this, so you load the help page here in this screen, and it will give you a short description of what it does, the arguments that it uses, and then details about the arguments. And then in lots of DataSHIELD functions nowadays, there is an example that you can run. And this, well, you can use this to work out how an actual working example, what the syntax, etc. is. This is logging into a different study called CNSIM, which is some simulated medical data. But CNSIM is also available on the training server. So now you've tried the help function, we'll actually run DSDIM on the data set that we're connected to. So some more syntax to do with DataSHIELD here. Very often, the arguments that you write into a DataSHIELD function, you have to write quotation marks around them. This is to do with the fact that it's being converted into a string and then sent off as a string to the server over the internet. So unless it's a local object, generally you need to remember quotations around it. And the help function will often tell you that quotations will be needed. So I'll run DSDIM. I'm doing this line only by doing Control and Enter. And here we've got in study 1, we've got 444 rows, 11 columns. In study 2, 447. And then the combined studies, so this is just adding the above two together. So again, often in DataSHIELD functions, aggregate type functions that bring results back to you will offer you the separated results and also the aggregated results. So what happens if I specify data sources connections? Well, connections is all of the servers that you've connected to. So that will be the same results. But here on line 139, it's specifying connections, just the first one in the list. So square brackets addressing a list. And we run that. And you see only study 1 results will come back. There's no study 2 specified in connections, so that doesn't happen. And then the aggregate doesn't have anything to combine, so it just takes what was in study 1. quickly here, I will have a look at the connections object on server. So as I said earlier, there's these simulated medical data sets that you can also connect to. But we are connected to the Newcomers workshop. Right. Oh. Right, so what else can we query about the data structure? So the column names, so we'll first load the help function of that. So X, the name of the input data frame, that's going to have to be in a quotation as well. And then specifying the data sources as before. So here we're going to specify D, because as we said at the start, that's what we're calling the data frames we're connecting to, and specifying all servers, so connections without any suffixed brackets. That one. So the names of the columns are survived P class name sex age. So that's similar to what we saw on the Opal portal online. But some of them are a bit confusing, or not confusing, but not immediately obvious. And that's where you would go over to the online portal to look at the data dictionary and work out what that actually means. But I think that one, for example, means the numbers of siblings or spouses that particular passenger had. Right. This section of explanation here is just telling you how to go onto the online portal, which we did earlier. So I'll just read this one out. So you need to stay aware of the limitations of a DataSHIELD analysis. So firstly, you can never directly view the contents of the data frame. So this is the core functionality of DataSHIELD, and it's a system to allow you to analyze sensitive data without viewing it or deducing any revealing information about the subject it contains. So it may be different to how you've used R before, but it is a nice challenge that you will get used to in the course of using DataSHIELD. And you have to find new ways of finding out the information you're interested in, and also work out if it's going to be allowed, because some things that you might be used to doing, like looking at the head of a data frame, just aren't allowed at all, of course. So what functions are available? Well, we have over 100 now, I think is correct. And there'll be a few more coming when DataSHIELD 6.2, which is the next version, releases in the coming months. So I'll transfer across to my browser again and go to this page on the wiki, which contains our list of functions. So these are not classified, grouped into certain types of functions. So you can just do a search, for example, if you wanted to find mean, you can go straight to ds.mean. Or if you wanted to find generalized linear modeling, GLM is what it's called in base R. So here it is, ds.glm, but there's also these GLM, SLMA, GLM predict. So a variety of things you can do for modeling, which you will have to read the documentation about. But yeah, this is useful to know. Go back to regular Studio. There's an equivalent function that you can run, which is ds list client-side functions. But unfortunately, it doesn't group them as it was in the wiki website. It's just a list in alphabetical order. So, oh, that's quite a big one. So I need to minimize that one. So let's continue on. So this exploration is going to be finding out how many missing values there are. So the function that we'll want here is numNA. If that doesn't strike you as immediately obvious, then you can go back to that wiki website and find it. Also, I might as well mention now, if you're really stuck for an analysis you're wanting to perform and just can't work out what it is, there's the forums, which are free and easy to join. And there's even a beginner space on there where you can post any question and you get very rapid responses there. And oh yeah, and weekly drop-in sessions on Tuesdays. In fact, I think there was one just before this. So if you can make them, we're willing to answer any questions you have about starting off your DataSHIELD analyses. So here we're going to be looking at the particular column age. So we're going to do our the name of the vector equals the column we're addressing inside quotation marks. So it's $age as you would do in regular addressing a data frame. Specifying all connections as the data sources. So that's showing that for age, in the first server, there's 87 missings, and in the second server, there are 90 missings. What about the length of DSH? Sorry, not DSH, of the age column. So that's exactly the same as the dimensions of the data frame as a whole. And then the non-missing data, so that's going to be the length of the column minus the missings. And then we're going to print the result. So 357 in each one. There's another function that you may have seen or you may see in the list of available functions, which is called complete cases. But this operates on the data frame as a whole. So it looks through every single row, and if there's an NA in any position on that row, it strips it out. So that's a bit different to what we just did in finding out how many missings there were in age. So it's important to note here that there is no output printed, but that's because we were generating a new object, but because it would be disclosive to view that new object, it was instead stored at the server side. And that property is known in DataSHIELD as an assign type function. So the data is assigned to the server and stored there, not brought back to the client session. I'm going to leave you guys to look for the error there. So looking at the complete cases, looking at the dimension of the complete cases, so that's ds.dim. So that's saying that there's only 87 rows in that complete cases object that was generated on the server side. That's quite heavily stripped down from the 891 cases we had in the full data frame. So if, for example, you were doing this in preparation for a generalized linear model, that's a function where it only takes in complete cases. So running a linear model on a fifth of your data might not be very statistically valid. But because this dsdim function is bringing back results and like numerical results and printing them out for us, the user, this is what makes it an aggregate type function. Right. Coding for time. Oh, only 11:40. Were there any questions to address at that point, Dimitri?
There are few questions, but I'm trying to respond on the chat.
If you want to respond by talking, if that's easier, we could use a break.
Basically, because I already written. There is one question: if someone want to use a function that is not already in DataSHIELD. Basically, we can always develop new functions in collaboration with the analysts, but this depends on what type of analysis you want to do. For example, if you want to develop an algorithm, if you want to develop a function that just calls some other native R functions, that's easy. Or there'd be very difficult if we need to develop an algorithm from the scratch, for example. And also, always when we develop a new function, we need to think carefully what information is needed to be shared, either from one, basically what information needed to be sent from the servers back to the client side. So we can discuss, if you want something specific, we can discuss. And also, in addition to the DS-based client package, which is what Alex is presenting, we have also a number of other packages that have been developed by the community of DataSHIELD. And maybe something that you want to do are included there. So for example, we have one package which is called DS mediation for mediation analysis, another DS exposome for analyzing exposome data. We have DS survival. So there are a lot of type of analysis that you can do without the need of developing something new. Let me check what other. So can we send a link to the course materials, maybe the wiki and the website?
Oh yeah. Do you want the link to the specific page on the website listing the various packages?
Yeah, there is also another important question about imputations. There was an initial development of a DS-mice package, but the package is still under development, and we have to do it at some point because a lot of analysts are asking for imputations. At the moment, you can only do simple imputations. For example, you can replace missings with the average of the non-missing values or something like that. But we are planning to include the mice functions at some point. Okay, there is another question where you can find out about the server log on details for the data you need to access. It's through DataSHIELD or the static consortia. Yeah, this is through the static consortia. And basically, when you do your proposal, I don't know in which project you are involved with, but most of the consortia, they have an online data catalog. And when you do your proposal, you always check in which cohorts that are involved in that specific consortium includes the variables that you want to analyze. And then you need to conduct each cohort separately with your proposal that is involved in this consortium. And depending on the cohort, in some cases, you have to to do a data access agreement, or there are different how it's called, different ways that you can get permission to analyze data depending on the cohort. But this is done from the consortium's side. DataSHIELD doesn't have any information about your credentials or about your data that you have access to. So in DataSHIELD, we just provide the tool. And another information that is important, if you want to analyze data, if you propose a project in a consortium, and in your proposal you are more than one people that you are propose a specific analysis, each person that is listed in the proposal gets different set of credentials. So if 2 or 3 people are working on the same project, you have different credentials to access the data. You are welcome. If you are using imputation, what algorithm are you using? Like, yeah, basically we haven't used any algorithm. We don't have functionality for imputation yet. But what we plan to do as a first stage of development is to implement the mice package. The mice package is using multiple imputation using chained equations. I'm not familiar with the algorithm that you mentioned here, but we can always include something more if you need. I'm not sure if I missed anything, but we can have a discussion later, Alex, with everyone.
Yeah. Right, I will continue. So the remainder of the demonstration part of the workshop is just going through a few different functions to show you a bit more of what's out there available to analyze in DataSHIELD and how to use them. So firstly, let's have a look at how to analyze discrete data. So one of the functions you can use for that is the table function, ds.table. Let's have a look at the help for that. So for generating contingency tables, so the usage, so here we actually have to specify the row variable, the column variable. If you're going for a 3-dimensional contingency table, you do the ST, I can't think what that stands for right now, but stvar. Then if you're wanting to do chi-squared tests, that's just built in, you'd set it true. Again, you could suppress chi-squared warnings, specify whether to use the missing values, that sort of thing. So let's actually use it. So firstly, because it's a function designed to be used on discrete data, we need to actually check that the column we're going to be doing it on is indeed discrete. So we're going to do that by checking the class of it using ds.class. So the object in quotation, oh, don't do that, in quotations is the data frame D, then dollar addressing the embarked column. Data sources is all the servers we're connected to, so connections. This is printing that in both the different servers, it is in fact a factor. That's good. So now we can use the ds.table function. So we're going to use this first argument here, rvar, only. We're setting that to the column we're interested in, the embarked. The data sources connections 1, so this means we're only looking at the first study. So first of all, you get validity check statements, and then error checks, no errors reported, that's good. Then you start looking at the printout. It's quite long, so these are proportions. So this is just saying 100% in each of these rows of the table. So that's not really interesting because it's a one-way contingency table. In a two-way, it would be more interesting. But if you do it by the column proportions instead of the row proportions, then you can see that 72% brought in S. S you'd have to go to the data dictionary for on the Opal portal online to find out that it's Southampton, and 18% in Cherbourg in France, and then 10% in Queenstown in Ireland, and less than 1% are NAs. So that's a very good ratio of missing values. And then after the proportions section, you get the count section. So because it's a one-way contingency table, there's only one bit of this printout, but here you can see the raw numbers. So Dimitri, I think it's right to say here, if it was Queenstown that had only one border there, that would block the whole table, right?
Yes.
Yeah. So that's the built-in disclosure protection for DS table, is if the numbers of a particular cell fall too low below the level that the data owner has specified. So the default, I think, for the training servers is 3. Then not only can you not see that row, you also can't see the whole table and the rest of the printout because we want to block you from deducing that that cell has 1 or 2 in it. So that's the active disclosure protection, and I guess its implications on, I'm looking for a word here. Yeah, its implications on disclosure by deducing from other results you get. So in all sorts of functions across the base DataSHIELD library, these kinds of overcautious protections are built in so that you can't do that. And then it's just the data presented in a different way, so across, but that's not too important until you get to two-way contingency tables. So now we'll actually look at one. I ought to specify data sources connections here. Separating arguments with a comma, important to note. So this is a bit more interesting. So this one sums horizontally. So those in the row add up to 100%. So this is saying of those who didn't survive, 15% were first class, 19% were second class, 66% were third class, pardon me. And then those who survived, 33% were first class, 26% second class, 41% third class. So that's how to read that. And then column proportions. this is now summing vertically. So those two add up to 100%. So of the people in first class, 42% did not survive and 58% didn't survive. And in third class, 72% did not survive and 28% did survive. So that, oh, pardon, that was only for server 1. So now it does it again for server 2. And then it combines all servers. And then once you're done with the proportion part of the printout, you get down to the counts. So this is the actual raw numbers of who survived. And you can see all these numbers are well above the disclosure limits set by the server. So well above, I think it's 3. So this is, oh yeah, this is just first study, second study, and then combined studies. And if you added up all these numbers, you'd get the 891 figure we had for the number of rows in the entire data set. So I've created a space here for the breakout session in case you wanted to create your own contingency tables. I'll just do a quick run of the chi-squared test to show you how that looks. So as before, all the validity checks, etc., all the proportion printouts, all the count printouts, and then you get below the $chi-squared tests part of the printout, and you've got your chi-squared, degrees of freedom, p-value, etc. So moving on, I'll minimize that because it's quite bulky. So moving on to slightly more simple stuff, refresh our memory of what the column names were. Right, so this is what we're going to have to address. So if we wanted to find an average age, could do ds.mean of the object in quotes, data frame address age, and also the variance while we're at it. So there's a slightly different mean per server, but it doesn't look too meaningful. Also slightly higher variance on the second study. What about different measures of spread? So medians and quantiles. So we'll do the quantile mean function, which you'll be able to look for in the list of available functions. So quantile mean actually also contains the median, even though it doesn't say it in the function name. So this 50th percentile, obviously the median. So on the first study, it's 29. Oh, no, sorry, that's the pool data, it says there. So the pool data, the median age was 29. And then slightly different on dataset 1 and 2. We can also visualize this, these spreads. So firstly, we can look at the combined using the argument type equals combine. That's an interesting skew towards younger ages, although not children. And then you can run it without combining them. So you get side-by-side histograms for study 1, study 2. Now, if you wanted to present these graphics differently, there is an option to use ggplot to download the anonymized data. It's important to note that these aren't the true histograms. They are, well, any of the small brackets towards the edges of the data are redacted if they get too small. So you're just seeing the bulk of the data in the middle. But that data comes back to the client side in anonymized form anyway. So instead of just printing the graphs here, you can ingest it into ggplot and create the graphs in the way that you want to present them. But that's something a bit beyond the scope of a beginner's workshop. Obviously, you're able to go on the forums and looking at other resources online for how to do that. I think we did it in the January 2021 workshop, which is on YouTube. So there's other graphs available. There's scatterplot, which we're about to do here, but there's also heat map, contour plot as well. So looking at the help function of scatterplot. So you've got two input variables and then a bit of detail about how the scatterplot is actually generated, and there's more detailed explanation of how it's done here. But yeah, Dimitri developed this, I think, close to when I joined DataSHIELD, so possibly about 2 years ago. So you can get it either deterministic or probabilistic. So if we actually print one, so this one actually has thrown an error because we haven't specified the data sources. So in the second line here, actually specify the data sources as being both connections. So we're looking at age against passenger fare here. So pretty random, can't see much of a trend there. So again, none of these dots are actually the true values of any of the elements of the data frame we're looking at. So they're actually randomized of the nearest neighbors. So that's here, k equals 3. So you take 3 true points and then use a method described in the help section to come up with an aggregated point between them. And in this way, it actually gets the general shape of the data if the data set is large enough. So since there's not much of a correlation, not much point doing a linear model on it, but there are tutorials available on our YouTube of where we actually do one that has a good correlation, and then ingest it into ggplot and plot the line of best fit on top of it as well. So that's it for showing you commands, but I'm sure we'll do a few more commands in the breakout session. Just want to note that it's very useful if you're going to use DataSHIELD for your upcoming research to save your workspaces. So, so this datashield.workspace_save. So firstly, I'll list the objects we've got. So we've got the data frame D and also the complete cases that we generated earlier. But now if we save the workspace and then call it 2022 February Titanic demonstration and enter that, and then list the, oh no, sorry. Well, then we log out using this DSI command, datashield.logout. Log in again, but using this restore argument with the name that we just specified earlier. And then we also list the data sources if we hadn't done this restore, it would have only had D here in each of the studies. But because we did the restore, we've got this D complete cases still here. Then we log out for final time. And that's the demonstration part over. So thank you for listening.
Alex, can you go up to the outcome of the histogram function?
Mm-hmm.
Because there is one specific question, but I don't remember the information.
I've gone too far. Have I? I've lost it.
I should be in below.
Yeah, it should be below.
Might be
not the scatter plot. Histogram, there we go. Yes, it was hidden.
Can you go up to see the information that is also returned from the function?
There?
I'm not sure if you open this console. If you open.
Oh, the console.
Yeah, can you open? Yeah.
Because that bit, yes.
Information about, yes, this one. Yeah, so this is breaks the counts. Wait, okay, invalid. Okay, so in that case, go up to the warning message.
Yeah.
It's saying that for study 1, we have one invalid cell, which means that one bin that includes one observation is not presented in the histogram, but we don't know how many individuals are included in that bin, and usually are less than 3 if the threshold that is used in that specific study is 3. We know that there are at least 3 individuals in that study. Is not returned, but if you calculate the sum of the counts, if you see the vector of the counts below, you can actually calculate how many individuals are not presented in the histogram. The other thing that is important, all these disclosure control thresholds are specified by the data custodian of each cohort. So for example, in some projects where you want to analyze, for example, rare diseases, the data cohorts might decide to use very small numbers for these thresholds. For example, they can say, they can set all these numbers equal to 1. So in that case, you can get the actual histogram. We recommend some minimum values, but this depends on the cohorts if they want to relax these thresholds or if they want to make the threshold more restrictive. It's up to them.
Okay, unless there's any more questions. So we're now ready to do the new part of the workshop, which is to let you try it yourself. So as you can see on my browser, I've navigated to the support Get Started Newcomers workshops, but I'm dropping that in the chat now. But here you can see that there's a link to Google Drive to download this R script that I've been working through. So anyone who wants to, you can go there and download the script, and then yeah, it's just a breakout, and if you've got any questions, if it's not working for you, please shout out. Also, don't need to just ask questions in the chat now, feel free to speak. Oh, another question, which is everyone planning to stay for the for the try it yourself section. If you're not, please message, because there's a survey. We'd really appreciate it if you filled in for us to say how we did here.
So maybe we can ask if it's good to have them breakout rooms, or we can just have a discussion.
Yeah.
Because we are not a lot of people. I don't know. What do you prefer?
I think we can create breakout rooms if multiple people start having questions. I'll set one up just in case.
Okay, so we can open the discussion if anyone has any question and want to put it on chat or unmute and say.
So it's just basically that we're going to kind of redo what Alex has done ourselves, just to make sure that we're comfortable with it. Is that?
Yeah, that's basically it. So if you run through the script, try running the commands, make sure you can connect correctly and install the packages correctly. And then if you want to, if it's all making sense to you, feel free to start customizing the functions to look at different statistics or do different graphs, and we'll be able to help you out.
Okay, that's great. Thanks very much for the presentation.
Thank you for the. Can you hear me?
Yes.
Yes, I want to thank you for the presentation. Also regarding the logging into the DataSHIELD. So we originally use logging in under DataSHIELD logins and then under our own. Is it correct? Do we need to register anywhere?
You mean to log into these training data sets?
Yes, where we are mentioning the Opal and Opal driver. Yeah,
but basically this is this Opal server is for training and it's open. If you use just the credentials that Alex included in his script, then you can log in without registering to anywhere.
Won't it override the work of other users though?
Yes, it's flexible to allow multiple users to run analysis on the same time and on the same data. And this is also happening in real settings.
Thank you.
Okay, so I've just managed to create the breakout rooms. So if you've got a specific problem with connecting or anything, just message us and we can go in a specific room to sort it out. But we'll all stay here for now. Yeah, if you're having any problems downloading the script, installing the packages, anything like that, do speak up. Just as a sense of how things are going, it'd be great if once you download the script and install the DataSHIELD packages, you could put a hands up in the Zoom call that you successfully managed to log in. That'll be really helpful. Ah, you go.
Yeah, I also wanted to ask, it's more of the technical question, how DSI is sensitive to the R version change? For example, when there is a major jump to R upgrade or R Studio update, will it work with the older version, or we should always check for the new version of DSI?
Certainly, in our experience, DSI isn't usually affected by an upgrade of either R or R Studio. We don't know what changes people will make in the future, but it doesn't tend to need to be upgraded for that. But it is good to keep it up to date, because there are sometimes more performance improvements being added.
I see. Thank you very much.
Okay, thank you, Shilpa.